In all actuality, do believe it's conceivable that at the second there's one progress in the smooth way heavenly. Wow, this is astounding. We will be advancing such a huge amount in the coming 10 years. Found 7 trillion miles away from Earth is an extraordinary revelation made by the James Webb Telescope. City lights in space. This noteworthy finding has touched off areas of strength for a wave of interest in the chance of extraterrestrial life. The telescope zeroed in on Proxima Centauri b, the nearest exoplanet to Earth, appearing with uncommon, splendid lights radiating from it. What could be answerable for these city lights on Proxima Centauri b? Could this connote the presence of life beyond our planet? Accompany us as we dig into how the James Webb Telescope recognized these remarkable objects in space. For a really long time, researchers and people overall have completed examinations to get a brief look at life beyond our planetary group. Any proof apparent to back up this dream about space has been happily invited over the long run. As of late, the academic community got the shock of their lives when strong proof of life forms existing in space was seen by the James Webb Space Telescope. While exploring space and relaying essential data back to Earth, the James Webb Space Telescope saw odd city lights sparkling from the exoplanet Proxima Centauri b. Similarly, as its name suggested, the city lights seemed as though they illuminated a far-off city. The chance of an alien city existing on the star has left researchers bringing in astonishment. All of them are confused because it appears as though this is the presence they've all been waiting for. Assuming that this ends up being valid, as everybody naturally suspects it will be, it means that there are intelligent life forms sorting out developments unfamiliar to what humans know in space, and we are just barely finding it. Looking into the city lights that are found 7 trillion miles from Earth, NASA engineers can't resist the urge to think about how long these lights have sparkled in space, waiting for humans to develop the expected innovation to identify them. David Kipping, an astronomer from Columbia University, depicts the Proxima b exoplanet where the city lights were found as interesting. He said so on the grounds that this star system, closest to us, has fluctuated warming patterns that aren't like different planets. The regular rocky planets are known to take in sunlight and discharge infrared radiation. However, it's not so for this exoplanet, as its infrared nature is very different from that of its host star named Proxima Centauri. This makes for a decent perception by the James Webb Space Telescope, JWST, and the telescope proved to be useful as the right instrument for the work. The JWST can without much of a stretch distinguish infrared frequencies. The characteristic heat mark of Proxima b will play an enormous role in finding the widespread secrets of its atmosphere. This will be due to the most recent innovation of infrared imaging capabilities had by the JWST. Researchers anticipate using the telescope to uncover the mystery surrounding this planet's climate and conditions. They likewise plan to utilize the Webb telescope to check the possibilities of living on this exoplanet. The James Webb Telescope has an infrared sensitivity that is expected to investigate what occurs on Proxima Centauri b's evening, picking up the slightest beams of light. In the inestimable dimness, it is typically a struggle for space telescopes. However, not for the JWST, as it can detect even the smallest beams of light from space. It's the ideal instrument to confirm if the gossip about city lights on Proxima's evening side is valid or misleading. Every artificial illumination in the universe can be detected by the telescope as long as it falls within a frequency band that is 1,000 times smaller than the starlight. How does Proxima Centauri b contrast with planet Earth? Proxima b has a fascinating connection between its heavenly highlights and surface interactions. The day side of the exoplanet contains quite a large number of solar panels that harness the percolating, brilliant energy moved by the star. The spectral edge additionally reflects infrared light beams. When Proxima b completes its orbit around its host star, Proxima Centauri, it encounters day and night time spans, very much like what we have on Earth, with the daytime getting high solar heat and the night experiencing coolness. The planet is known to have temperature variances determined by its composition. For example, assuming that there's no atmosphere on Proxima b, the contrast between its day and night time spans will be wide and far apart. In the event that there's no significant influence of atmospheric gases and oceans, the temperature of the day side will be so hot like a black body, and the night side will drop into cold obscurity. The level of temperature variety is a great subject for astronomers to unwind a deeper understanding of Proxima's air structure. having an unmatched infrared imaging capability. The JWST can effectively examine the planet's thermal emissions to provide insightful data about its environmental properties. Strangely, the orbit of the JWST around the Earth falls in alignment with Proxima B's orbital period, making complete observations of its day and night time spans within 11 Earth days. If it indeed has an atmosphere, the next step will be to evaluate its atmospheric composition to determine if it can accommodate life. Some key indicators in determining if there's life are the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it implies that it supports habitable conditions. The process of effectively determining this requires scientists to be meticulous as they capture and analyze light beams that travel through the planet's atmosphere. This is an incredibly challenging task to undertake, even if the JWST has excellent abilities for characterizing planetary atmospheres. It has a significant limitation in detecting bonded oxygen, which is a vital sign of life. Nonetheless, the telescope still has substantial reasons to search for other elements on the planet. One of such reasons is ozone, which indicates a level of vitality in the atmosphere. It's also worth noting that the James Webb Space Telescope doesn't have absolute capabilities and can only peer at a few of the closest habitable worlds to Earth. Conducting a thorough atmospheric analysis, astronomers are now leaning towards ground-based observatories like the Extremely Large Telescope (ELT), affectionately referred to as ELT. The ELT is a telescope that is scheduled to start working in 2028 and is carefully positioned to look further into the environmental structure of distant exoplanets. It will provide data on these planets, offering comprehensive and striking insights into their habitability levels. NASA scientists and everyone are eagerly awaiting the deployment of future space telescopes like these. Until then, the James Webb Space Telescope will continue to be a fundamental tool in our quest to uncover the secrets of distant exoplanets. Even with its current limitations, the James Webb Telescope has the potential to provide profound insights that will transform our understanding of exoplanetary exploration. Now and in the future, scientists have an objective for future space telescopes: to reduce the amount of bright light coming from a planet's host star so that astronomers can clearly see the lights reflected from a planet itself. They plan to do this by using internal masks or massive external satellites shaped like umbrellas. This is akin to using your hand to block out the sun's rays, allowing you to see an object more clearly. That will reduce the fierce brightness coming from the host star, and future telescopes will be better positioned to study faint impressions of light coming from a distant exoplanet, enabling a clear investigation of its climate and probability of supporting life. Doing this comes with its own challenges. Scientists must differentiate between gases produced from biological processes and those generated from geological cycles, such as volcanic activity. Astronomers aren't yielding in their bid to understand the characteristics of exoplanets, so they're more prepared to find indications of life and distinguish them from false positives. The Webb telescope contains a suite of scientific advancements from the study of exoplanets, offering a sneak peek into the astonishing discoveries we're yet to find. As we stretch our understanding and exploration of the universe further, we are better positioned to comprehend the workings of the universe and our roles in it. Despite searching through all the planets in space, scientists have yet to find any that have life, despite decades of scanning space for signs of life. The quest for forms of life on other planets continues. Are we alone in the universe? For centuries, throughout human civilizations, people have consistently wondered if they are the only ones living in the universe. This is an age-old yearning that still hasn't left us. Even now, researchers have the James Webb Telescope in space, attempting to identify alien civilizations hidden among us while studying various planetary bodies for signs of life. At the same time, the narrative that some aliens are indeed something else in the stars, just waiting for humans to find them, is a popular story. To give an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence in 1984, known as the SETI Institute. This is a non-profit endeavor that aims to sift through cosmic signals to capture radio transmissions from space. Radio signals can travel long distances without being scattered or absorbed like other types of radiation, hence their choice to focus on them. Because of this characteristic feature, radio signals are more likely to be detected. The 42 radio telescopes that constitute the Allen Telescope Array are located in the Cascade Mountains of California. However, the SETI Institute has strictly monitored these radio transmissions created by alien life, and there haven't been any such signals for over 30 years. Jill Tarter is optimistic that they'll have a positive outcome, as they need to use the instruments of the 21st century to accelerate the search. In the words of Jill, "I wish that you would engage Earthlings everywhere to become active participants in the ultimate search for a cosmic company." Are there any other ways to detect alien life in space besides capturing radio transmissions?